right, I'm going to get started. I want to thank you, everybody, for coming and attending this this event. I've got some wonderful speakers today. I just want you to all know that this will be recorded. So this is currently getting recorded right now. So if you have any questions, please, or concerns, you probably have to at least let you know about that. And by the way, my name is Jason Bruns. I am the director of the Minnesota State Engineering Center of Excellence, and I am proud to see and to have these participants, these great instructors, speak about some of the stuff they are presenting at the ASEE conference. This event here is the Engineering Technology STEM Educator Workshop, where we try to bring you some content to help you with your pedagogy, maybe some styles and techniques that other people have created and developed. So hopefully it is a great sharing event. I really look towards this to be an opportunity to be able to share and ask questions as well. So ensure that you keep your questions in your mind, and there'll be time to be able to have these wonderful people answer those questions for you. So I want to thank my panelists or my presenters, Rob and Elizabeth and Lauren, and I'm going to go over a little bit background on them as well. And just to let you know, a couple of housekeeping items as well. There'll be a survey coming out tomorrow. Please fill that out. That just makes us make the program better, get us better on what we need to do, and really help identify things that you might be looking for as well. So what can we do to continue to have this program evolve, to continue to bring you some more good content? Like I had mentioned, we'll have this available. It's currently being recorded, and it'll be available on our website as well. And those people that are wanting professional development, all you have to do is at the end of this, please email me, jason.bruns@mnsu.edu, and you can go to our website as well to find that out, or to get that information and to be able to contact me for that professional development. I'm always willing to help you out and make sure that you've got your professional growth coming out of this as well. So I'm going to do the introductions. Introductions are going to be our featured speakers that I mentioned earlier. Rob Sleezer earned his PhD in microelectronics and photonics from the University of Arkansas. He attended Oklahoma State University, where he graduated with a BS in computer science and an MS and BS in electrical engineering. He's currently a faculty member at Twin Cities Engineering, which is in the Department of Integrated Engineering at Minnesota State University, Mankato. Elizabeth Pluswick leads the Engineering Economics, Entrepreneurial, and Lean competencies at Iron Range Engineering and Twin Cities Engineering, two project-based engineering education programs of the Minnesota State University Mankato system. She also facilitates statistics, leadership, teamwork, communication, and professionalism learning with the engineering students. Before joining IRE in 2012, Elizabeth was a faculty member in the College of Business at St. Ambrose University, Davenport, Iowa. Her industry experience includes 5 years as a controller with MSI Mold Builders in Cedar Rapids, Iowa, and 4 years as an auditor tax accountant for McGrader and Pullen CPAs in Cedar Rapids, Iowa. Her PhD in Organization and Management is from Capella University in Minneapolis, Minnesota, and her research interests include Lean and Six Sigma, two places that are very near to my heart. Project-based learning, managing change, and integration of engineering and business to best prepare engineers for successful careers. Having been raised in Virginia, Minnesota, Elizabeth enjoys kayaking, hiking, photographing the nature beauty and northern Minnesota's wilderness with her family and her friends. Laura Singelman is a PhD candidate at North Dakota State University in electrical and computer engineering and STEM education. Her dissertation work focuses on using machine learning and data mining to better understand how engineering students work together to create innovative solutions to real-world problems. More broadly, she is interested in combining data analytics and learning sciences to better support both students and instructors. She also serves as an adjunct faculty member with the Iron Range Engineering Bell program and as the NDSU College of Engineering STEM Outreach Coordinator. So I want to let you know that. I welcome all my guests. Thank you for all coming. Mr. Rob Sleezer will be leading us off today, and he'll be discussing the impact of project-based engineering on the engineering stress culture. Elizabeth and Lauren will then come back with machine learning analysis of student written work to assess motivation. And Rob will then conclude with Orange is the New Engineering, Reflections on Teaching Engineering in an Incarcerated Setting. So thank you, and I will stop sharing and I will let Rob take over.
Thank you very much, Jason. I really appreciate the introduction. Let me make sure I'm sharing the right screen here. There we go. One of the things that we know about engineering is that it can be very stressful, not just for engineering practitioners in industry who are working on high stakes projects, but also for students who are pursuing an engineering credential. And so there was a study that was published in the Journal of Engineering Education relatively recently, and I'll show some results from that later, that looked at how students perceive the stress culture in their experience and in their department. And then we looked at the same measures. We replicated that study in our context, which is a little different. And is a project-based context. And we'll talk a little bit about what that means momentarily. As I go through this, if you have questions, comments, concerns, or would like to discuss things, please jump in and stop me. I would love to break out of this and make this more interactive. I've also tried to make sure to build in some time for discussion later.
And Rob, I'll fly flank for you as well through the chat, just to let you know, okay?
Appreciate it. Thank you so much, Jason. So, the big takeaway from our research is that our project-based engineering programs result in a different stress culture, less stress, less depression, no change in anxiety, a stronger association with engineering. Our student engineers associate more strongly with an engineering career than do students in the traditional program studied by Jensen and Cross. And they also perceive, very importantly, the department, a much stronger sense of inclusion with their department. So that's the end of the presentation. That's the last, that's the thing. So that I will be building towards. So you can keep that in your mind as we build towards that pinnacle. What does engineering school do? Well, engineering school prepares students to enter the profession. And we ask students to go through a lot of challenges on that way, hoping that when they get into the practice of engineering, they will be effective and efficient in that space. We want them to come in as students, graduate, and then go make money and ideally donate some of that money back to our institutions. And so we give them lots of challenges. We ask them to look at a lot of data, analyze data, conduct iterative design. We ask them to solve lots of hard math problems. And if I picked some of these things and ask you to solve them, you might perceive a little bit of stress if you weren't, you know, you've probably seen all of these things once upon a time, but you might have to dust off some knowledge. And if I ask you to solve this on a quiz in the next 3 minutes, it could be stressful. And so when we ask a student to navigate this journey, it can feel stressful to them as well. And as sort of an aside, I had a student in my office yesterday, and in speaking to them, I was describing what I was going to present, and their response was, yeah, it's a lot like that. You know, we navigate this fearful thing, but our hat's on fire. there's more stress in this. And not only are these problems, unknown to us, they are legitimately scary. And so we don't see necessarily the math problems or the engineering problems or the physics problems. We see all sorts of monsters, things to be terrified of. And you're asking us to navigate that journey with our head on fire. And that can be a really, really stressful experience. It can be an isolating experience. And so thinking about how this experience includes and excludes different groups of people can have value. The engineering school process should be selective. It is important to me as a professor of engineering that engineering remain exclusive. Only the people that are good at design, the people that have an ethical foundation and think about others, only the people who can apply strong technical competence to real world problems should be in engineering. And yet I also think that a lot of people who are currently being excluded could be included if we changed our structure slightly. And so there's this balance of thinking about inclusivity versus exclusivity in engineering. And there's a natural tension there in the engineering education space. So let's look at a specific example of how students may interact with an educational environment. This is a graphic that represents a student trying to overcome a challenging assessment. And oftentimes, educators will design that assessment to provide a roughly normally distributed population, and they may be required by an institution or have a formal statement on their syllabus that anything above a 90 gets an A, above an 80 gets a B, above a 70 gets a C, above a 60 gets a D, and the rest fail. And if we have something that's normally distributed about 50%, you can see a small fraction of people are going to be successful in passing that course. And as an educator, we know we have a different perspective. We maybe know that the real picture is going to look like this. However, the students don't necessarily know that. Additionally, they don't know where they are on this curve. So even if they know that we are going to adjust our weighting, they don't know where they lie on this. More importantly, there are challenges with asking students to engage collaboratively in this space. Oftentimes, we will ask students to work together to partner, and then we grade them in this competitive manner. In this setting, somebody who does worse improves somebody else's score, somebody else's grade. And so that can set up feelings of isolation, that can set up feelings of resentment, that can set up behaviors that we don't want. And so that can lead students to some fairly challenging thoughts. These are largely associated with imposter syndrome and can drive many of the students who would otherwise be very well qualified to work in an engineering space out of engineering education. They may question whether or not they belong, more because of the competitive environment and the artificial stressors than the actual engineering experience. And so a project-based engineering program, we're getting into what our programs look like here, will change fundamentally the interactions between people, moving the assessments to be more authentic, more real world makes a difference. Changing the dynamic so that when people work together, they win together. Changing the proposition from me as a professor putting up a challenge that's artificial and making students jump through my hoops to joining with them in encountering challenges that are real world, challenges where I don't have the best answer. We know in engineering, you have to explore the space around you. You have to develop new solutions. And so we need, if we explore this together, if we face this together, we can overcome these challenges jointly. We're no longer in a space where it's a professor versus a student and you have to get through me to graduate. Rather, it is me as a facilitator of learning, helping provide the scaffolding such that you are able to navigate and effectively deliver a strong solution to an engineering problem. And so we measure how this affects stress culture with 3 components. And this is what the Jensen and Cross study did, that study that we're comparing our programs to. The 3 components start with mental health. And mental health is made up of depression, anxiety, and stress. Professional identity, that's made up of your engineering identity and also your ability to perceive yourself as a future engineer, what your career looks like in the future. And then finally, we have your sense of inclusion in the department. Do you feel included in the department? And that's measured by department caring, by department pride, and by department diversity. Jensen and Cross surveyed, a Midwestern institution, lots of students, that kind of a thing. We focused on 3 programs, 3 project-based programs. 2 of them are engineering programs. And then we also included a computer science program. Twin Cities Engineering is the program that I'm with. Bell Engineering is in the same department. It is a little different program where students come from actually across the nation and go to the Iron Range, where they do an intensive experience, learning experience, and then go back and do co-op experiences in industry coupled with distance education, and do that 4 times to earn an engineering credential. And then the computer science is a new computer science project-based program on the main campus of Minnesota State University, Mankato. I think our first graduates will be coming out of that this semester, and we're really, really excited. Here, I'm going to really focus on the program that I'm from, the Twin Cities Engineering program. So a quick picture of that to set the stage a little bit. Really understanding this requires a long time, maybe a couple of semesters. We have students that get through this program and they go, oh, I get it. That's the way it works. So there's a lot of sort of unusual aspects. A student begins by completing 2 years of pre-engineering work, including general education. That general education may fade out, and they may take some general education while they're in our program as well. Once they're done with that, they'll do that at some place, any place. They could do that with one of our community college partners, with the Minnesota state system. We've had students transfer in from out of state. We've had students come up from the main campus, lots of different places. Wherever they do that, we work to help them wrap up any lingering pre-engineering requirements they have and then transfer into our program. In our program, they participate in a project each semester that is roughly the equivalent of a capstone design course. They get 6 credits for working on this project. 3 of those credits are in what we call design. That is everything to do with their project that is the actual engineering. 3 of those credits are called professionalism. That's everything to do with their project that is not the engineering. The longer I teach engineering, the more I am convinced engineers spend very little time engineering. Most of their time is spent preparing to engineer and wrapping up engineering. Doing all of the communications, doing all of the client interactions, doing the reporting, you know, a lot of the meetings that suck up a lot of time, and then the actual engineering happens for 3 minutes on a random Wednesday in the, you know, middle of some month. Professionalism and design are what we call doing courses. Students get credit for actually submitting the work. Those courses don't really meet for faculty to provide content to student engineers. Those may meet for student engineers to provide content to faculty, but they are generally not a space where we actually teach. So to support learning in professionalism and design content, we have a 1 credit seminar class that meets weekly, and students come into that space and learn things that they could apply in their project setting. That represents about half of the credits a student takes in a semester. The other half of the credits students take in a semester are technical competencies. These competencies ideally connect to and support the project. So students maybe are studying AC circuits, and they are able to apply AC circuits and build filters and think about filtering specifically for their project. They do this 4 times and then they graduate. And so that's on the path to going out into industry, making money, and donating it back to the university and the department. When we look at the different measures of stress, professional identity, and departmental inclusion, we see some good results. We've got also the results for computer science and bioengineering, but I kind of wanted to focus here. There's a lot of things, and you can start asking questions about standard deviations and all sorts of fun statistical things. And at the end of the day, it comes back to this slide that I started with. Our engineers have less stress and less depression. They more strongly associate with going into an engineering career. And they perceive their department to be more caring, more diverse, and they are more proud of their department. So there are some limitations to this. This is still sort of a relatively small population. So doing some replication is going to be important in moving forward. Also, we have some thoughts on the mechanisms behind this and the whys. but really digging into that is going to require some substantial qualitative research. And so those are our next steps. And that brings me to the end of what I have prepared, and I would love to engage with any discussion or answer any questions you have.
Thank you, Rob. That was outstanding. I appreciate that and enjoyed that. Any questions from the group? We can put Rob in the hot seat in. Okay. Seeing none.
I do have a question.
Oh, yes, please do.
Yeah, I was wondering, you were talking about some methods of grading that can make people feel isolated because they're competing with their peers, and so they don't want to work with others because that might bring their grade down, maybe.
Sure.
So is there a method of grading that could encourage collaboration?
Yeah, so there's a few different things that we do in our spaces, and this is where maybe more qualitative research needs to be done. So I'm sort of hypothesizing a little bit and talking about some of my personal experiences, but there's not as much rigor here. So one of the things that we do is we actually use words to grade. I have a 1 to 5 scale that I grade on, and the words that I grade on are exemplary. This is exemplary work. If work is truly exemplary, the whiteboard behind me will be so impressed and so in awe of what you have done that it will be crying tears of joy, right? It's hard to do something that's truly exemplary, but it happens, and I am so excited when it happens. The next step we have is something that is desired. A lot of things fall into the desired category. This is, you are performing at the level I want you to perform at. And if you're doing that, that should be a pretty solid grade. Next, I have adequate. Adequate is for sure passing. It's maybe even a strong passing. Then I have weak. Weak is on the border of passing. If you're performing weakly in an area, you're just on the border. And then we have deficient. And so when I assess, I use rubrics to do these assessments, and I assess according to those words. And when my student engineers perform at a desired level, I state that very clearly. And multiple students can get there. There's no curve at that point, right? At that point, I have decided already desired outcome is desired outcome. And if I'm failing desired outcome, that's a bad thing. So in some ways, it's a reframing of my approach. I don't know. Does that answer the question?
Yeah, I think so. Yeah, thank you.
I think the other piece to it is that we do a lot of group assessments. So I work very hard to give exams that are fairly authentic and look for people to explain what's happening. I do all my assessments in exams tend to be oral, which is hard to scale, but possible. And so, and you can use whatever resources. How often in industry do engineers not have the ability to look something up? So I'm really looking for that application part.
So it sounds like the students are almost competing with themselves to get a desired grade rather than trying to outperform somebody else.
I would say there's part of a competing with themselves. I would also say they are competing against, as much as possible, what I make an authentic experience. Right. So I don't come up with a random differential equation and say, if you can't solve this differential equation, you're going to fail my class. Instead, I try to say, we are interested in, getting this signal. How do we figure out how to get that signal? And there can be a lot of paths to that. And so if they can achieve that, then that's where they get a strong performance.
Great, thank you.
Very good. Anybody else? That was wonderful. Rob, that was great. Love the content and love the delivery. So thank you for sharing. We'll go on to our next group, Elizabeth and Lauren. They're going to talk about machine learning analysis of student written work to assess motivation. So Elizabeth, I'll let you take charge. Still on mute?
Thank you. Yep. Thank you. I have construction going on in the house, so I'm gonna unmute. I'm gonna mute when I'm not speaking. Thank you. Okay, I will share a screen. I'm Elizabeth, and Lauren is with me. And just for your background, that was great to have Rob speak first, because Iron Range Engineering is a sister program to Twin Cities Engineering. So a lot of what Rob described. Now let's see if I show present. Is it going to change? Oh well, we'll just do it this way. That's fine. A lot of what Rob present is particular and similar. Most of what he said is very similar in the Iron Range Engineering program. So with that context, that sets the stage for our study dealing with motivation and educational data mining is in a similar context, similar program, similar students to what Rob just described. So that worked out really well. So I'm Elizabeth Pluswick, Iron Range Engineering faculty member there. Lauren, you want to introduce yourself quick?
Yeah, I'm Lauren Singelman. I am finishing up my dissertation at North Dakota State University, but then I also work with the Iron Range Engineering Bell program, kind of wearing a variety of hats as I finish up my PhD here.
So in that context of students learning, people learning education, learning in engineering education, as Rob described, learning how to be engineers, how to be work-ready engineers, we wonder about students' motivation to persist through that stressful, challenging environment that Rob described. So we're curious about learners' motivation. Where do they come in? To what level of motivation do our students come into our program in their third year of engineering education? And does their level of motivation change during the years that they're with us? It's only 2 years, sometimes 2.5 years that they're with us. As they're going through project-based learning, working with industry clients, how does their level of motivation change? Can we have any insight into that? So we wondered if their written reflection work could give us any clues as to what's going on in their hearts and minds and emotions about their level of motivation at school and about their projects and just their engineering preparation as a whole. Wouldn't it be neat to really get an inside view into what's going on in learners' heads as they're struggling through, but having fun, working with teammates, working with peers, doing social events, navigating through becoming the engineer that they want to be. Wouldn't it be neat to get a little insight into what they're thinking and feeling? We don't have a perfect way to do that, but we do have our students write a great number of reflections during every semester. In the design class, as Rob mentioned, we have them write reflections on 3 prompts per week. So that's already 45 per semester. And then more reflections for each technical competency and professionalism and documenting their engineering work. So our students are writing a lot of reflections. And we know that writing what you're thinking and what you've experienced, writing about it is a really good, really effective way to deep learning. And so we wondered, we have all this data, we wondered if machine learning, educational data mining could help us explore some questions on student motivation and how it changes through their experience. So we did complete a pilot study that so far has promising results. Lauren has the machine learning algorithm and I have access to the data. And so we collaborated and did a pilot study last fall. And now we are continuing with a larger study, but so far we've had promising results. So we'll get more into the framework and the data in a minute, but just to tell you that the data is from written artifacts, so reflection writing from 3rd and 4th year students in engineering in our PBL program. And the machine learning algorithm that Lauren developed and we've been using does differentiate key words used by students with faculty assessed high and low levels of motivation. So in this first study, I, just as their faculty member, I knew these students in the past. This was from data of spring of 17. All the students had graduated. So I remember them and I thought, that one seemed to have high levels of motivation. That one seemed to have lower motivation levels. And so I coded the text, the written documents that way, and how I felt. And then we used Lauren's machine learning algorithm to pilot and teach and train the algorithm, and then see if it correlates at all with my human assessment and human perspective. That was just the pilot study. We have lots more going forward, but that's what we're reporting on today, is that pilot group.
So a quick introduction to machine learning. It's starting to appear in many of our day-to-day things that we encounter. So whether you have noticed that Google Maps will now tell you, oh, actually we found a shorter route, so maybe you should take this way. If you are on Netflix or Amazon and getting those recommendations. But we're also seeing machine learning appearing in the education sphere. So you see Pearson up here, the logo for Pearson. They're taking their online textbooks and figuring out, okay, is it better if I have the figure right here and the caption here? Is it better if I share this concept first and then this one? What do I know about what a student knows based off of how they're answering these questions? All of these different pieces of data are then being analyzed and allowing us to get a better insight as far as human behavior, and then what we can do to intervene or support, whether it's trying to find your next Amazon purchase or trying to figure out, okay, how can we best support students? So I'll have Elizabeth go to the next slide here. So to talk about my own view of learning analytics, it's thinking about how can we use these findings to support us as educators. So I'm not saying that computers are going to come in and take our jobs and that we'll be free to just hang out. I'm saying, how can they better support us? If we have lots of pieces of data, machines are really good at finding patterns in that data over time. They're good at finding quantitative trends, and they're good at helping us reduce all of those pieces of data so then we can apply our own understanding of how students learn, our own context of the situation. If we have a personal relationship with a student, for example, the algorithm give us information that would be helpful that we might not have noticed otherwise. So it's really these two pieces working together. All of these pieces of data and these patterns, but then also our own experience and expertise that we bring, whether you're an education researcher or an instructor in a case. So next slide. The algorithm that we use is a classification algorithm. So just really briefly, we're taking all of these learning journals and we're making them into a big matrix. So Rob talked about that sometimes we feel anxiety when we look at math and engineering problems. So we'll try to just give a brief overview of this. So bear with me, but we take these matrices, we then are able to separate low and high motivation by taking a statistical approach and figuring out, okay, based off of all of these words, which words are most likely to differentiate our high motivation learning journals and our low motivation learning journals. We can then compare what we expected to what the algorithm told us, and then we can pull out any of those important words and better understand what sorts of clues might exist in our data to differentiate high and low levels of motivation. So I'll pass it back over to Elizabeth here.
Thank you. So we started off with 3 initial research questions that we addressed in the pilot study, and we did get good answers to these. We feel solid answers to these preliminary questions. So our pilot question 1, can a machine learning classifier be trained to analyze learning and differentiate between high and low motivation? Question 2, I'm sorry, can you hear me now? I'll just let you read. If the classifier model has sufficient performance, what types of words and phrases are most likely to differentiate between low and high motivation? And our research question 3 in the pilot, what types of learning journals most highly correspond with overall student motivation? as reported by faculty observation. So those were our initial research questions. And we put together this framework to show our study, current and planned, and also to show what we control and what we can't really control, and what we're measuring. Motivation is a progressive state. This is experienced by the student, the motivation, a progressive state in the student's head, heart, you know, how they act, behave, and think. This is really what we're measuring as they become the engineer that they want to be at graduation and beyond. The inputs to that are learner perception, and we can't control their learner perception. They come in with background, experience, attitudes, beliefs, and we can't control those. They are what they are when the students come into our program. We do have some effect on the learning environment. We can change that. We can change the types of reflection questions that we ask. We can change the types of projects that the students work on. We can get new faculty members, call in industry guests. I mean, there's a lot of, have a dress code, not have a dress code. I mean, there's a lot of things that we can change in the learning environment to make it more motivational for students as they progress through engineering education. So those are the inputs, what we're measuring, and the outcomes that we're hoping for. What we're measuring right now is the reflection journal prompts, their responses by machine learning algorithms and by faculty observation. In the future, to ask about self-report and using externally validated surveys in 2 to 3 years. This year in the pilot, we've done this bit right here. I hope you can hear me. So we're interested in how do our project-based learning engineering students come into the program, with what motivation levels do they have? Can we place them on this motivation continuum? And then how do they maybe change and progress through the motivation continuum? We hope that they progress forward towards more intrinsic motivation, categorized by sense of volition, pleasure, energy, persistence, deep learning, performing well, gratification, all those elements of internal intrinsic motivation. We don't want them to progress backwards, you know, from where they come in at. So it goes from extrinsic, well, first of all, passive, avoidance, oppositional, insecurity, fear of failure, resistance, apathy is the A motivation. And then we're moving through extrinsic motivation. And that is doing something because someone tells you to, like a positional power of the faculty, you know, can exert external pressure, or internal pressure that the student puts on themselves and from their team members. So we don't want any of this, but we're wondering, where do our students fall when they come into the program, and then how do they move through their 2 years through upper division? Okay, Lauren.
So our data set stems from these reflection prompts and these learning journals that students complete 3 times a week. We separated the learning journals into multiple different categories. So you can see just briefly here, our first category and our last category. So questions about design, for example, how should your experiment results be reported? All the way to extending to future, thinking about what does lifelong learning mean to you? How do the experiences that you're having apply to your future as an engineer? So throughout all of these responses, we separated them into these 6 different categories to get an idea of not only can we differentiate between low and high motivation, but also do any of these categories give us more insight into student motivation as we go. So our next slide. So our preliminary results. So once again, this was a really small starting data set. So as you're looking here at the words that are differentiating between lower motivation and higher motivation, some of the words like the word it or things, for example, aren't necessarily as meaningful. But we did see some really interesting things, especially in the high motivation side of things. And some of these words correspond really nicely to that motivation continuum that we saw in the literature as well. So looking at words like team, commitment, values, some of those things the algorithm noticed, this differentiates high motivation students from low motivation students. And we also see that coming from the literature too, that some of these things relate to that motivation. So as we go, we'll continue to find these differentiating words, and that might help us as we move forward to being able to differentiate between different types of motivation and really help us map these students over time. So our next slide here. So we also, like I said, we wanted to see if there are any specific types of learning journals that help us get a better idea of where a student is at. So a learning journal is kind of a snapshot in time of a specific student and how they're feeling. We wanted to see, are there any snapshots that give us an idea of the bigger picture? And what we found, so our axis over here is looking at error. So any category that has low levels of error will be more helpful in helping us see if that learning journal also corresponds to overall motivation. And if we go to that second slide there, we see that of all of the different categories, when students were writing and reflecting about their future, that snapshot in time gave us a better idea of their overall motivation as well. So as they were reflecting and looking to the future, that helped us see, okay, is the student feeling down and have low motivation overall versus are they feeling good and that they're looking ahead? So thinking about, for example, sometimes when you're writing about a class that's maybe frustrating, you might see that that learning journal, that snapshot has low motivation, but that doesn't necessarily mean that that student isn't overall motivated, which we see from looking at all of those other categories. Whereas with the future, it does give us a better idea of how they're feeling overall.
So as you can imagine, we have a lot of future work, and we're both really excited about the future of this project. Not only for the educational data mining aspect to use the algorithms for qualitative research, but also to improve our programs, to improve our types of reflection questions that we ask students to write about, to improve the context of our learning environment. And the experiences that students go through to support their motivation as they move through the program and graduate. So some of our already written future research questions are: how do the results of the machine learning classifier, that's the algorithm, compare to other measures of student motivation? We haven't asked the students particularly yet to rate their motivation level. That will come up in the future. Faculty observations beyond me, but to use a more comprehensive group of faculty to give their opinions on students' levels of motivations. And then externally validated instruments that students can take to assess their level of motivation. And I do want to say that we have IRB approval to use the written reflection work to only of students that have already graduated. So we're not impacting current students by looking at their reflection journals. The students don't know that we're using this for research. We're only using data from past semesters as students have already graduated. So again, in a future question 2, we'll continue to look at how do students' levels of motivation change as they progress through the program, project-based learning. And another one is how are ideas written in the learning journals connected to each other? How are they communicated? How do the learning journals compare to the existing literature about student motivation? And Lauren, you can answer any questions on the epistemic network analysis to kind of connect thoughts and ideas and ways of communicating trends as we look at the access to 10 semesters of student reflection writing now. And so this is a very rich database that we're hopeful that the machine learning algorithms, and as Lauren continues to code them, will give us insight into these questions in the future as well. So really we're up to the time for questions, thoughts, your ideas. What do you think about this? Do you think it's valid? Do you think of any changes that you might want to make in your own program, and any suggestions for our presentation or our study overall?
Thank you. Thank you. Thank you. Are there any questions out there? I'd like to throw that out there and see if there's anybody that would like to throw a question, because I've got a couple questions of my own that I seem to come up with.
Hello. Mary Ellen Murphy here. My my question is, I'm, completely outside of the academic situations and teaching experiences at the moment. However, I've done a lot of middle school and teaching in STEM. Mind you, I am a teaching artist and would be someone who wouldn't necessarily fit into any of these programs. However, have a very deep interest in this. My question is, do you ask them anything about their experience of of their encounters with STEM or engineering in that particular time frame of an educational space? And the reason I bring it up, in part responding to the previous presentation, is that one of the things that we teach is called, cooperation. So there's got to be a certain level of cooperation and competition within the groupings that are created, or teams, and so on. I have a K-12 and college level teaching experience, but to me, I think really that's where we as educators and thinkers need to be focusing our attention. And I think perhaps it's from the spark and space of that experience that you actually have some engineers in that, pre-engineering, what's their experience that got them there. And so I'm also quite curious about rubrics and teaching and so on. But that's my question is, do you get anything about that as a trigger to the persistent motivation of getting them into engineering versus whatever or not?
Yeah. Yeah, that's a really, really good thought. That could be a whole research project on its own right there. We do ask a variety of questions on teamwork. Well, in the weekly reflection prompts, we ask a variety of questions on teamwork. What did your peers do that helped you in the project? What do your peers do that hurt the project or impeded your progress? In the weekly professionalism questions, we ask questions about their prior experience, about their current work-life balance, and a lot of things like that. Also in the design class itself and the design project, there's a team grade, like Rob was talking about how we grade this collaborative work. At Iron Range Engineering, there's a team grade that the facilitator assesses and gives a lot of feedback on teamwork. So there's a team, everyone gets the same group grade, the team grade at several points throughout the semester. But then there's another grade for individual contribution. So a individual's group grade could go up or down based on their individual contribution. And we use 360 evaluation for that. So the peers evaluate each other, the facilitator evaluates, and then a whole panel of faculty and facilitators evaluate the project written work through their documentation, their CAD drawings, their deliverables for the client. So there's really a 360 holistic assessment process that students go through step by step. And so we encourage collaboration. We encourage when one student does a deep dive into a technical topic, we hold the whole team accountable for how did that technical topic help your team solve the client's problem. Mm-hmm. So we encourage collaboration. We hold each other accountable for what that one learned. You're going to be graded on partially on what they learned and taught you, and were you paying attention to how this contributed to the design direction and design decisions of the team. So there's quite a lot of prompts and scaffolding to encourage collaboration. And occasionally we'll ask questions about their prior experiences, what got them into engineering. I'm the one who writes the reflection prompts at Iron Range Engineering, so I have the opportunity to put in specific reflection questions now that we can use in the future to analyze along with the machine learning algorithm. So does that at least partially answer your question? Yes. I love your question.
Yeah, I'll add one thing too, just looking at the results, the top most differentiating word for positive motivation was team. So I think that ties in right with what you're asking. And then we also see some of those words that I would tie with this idea of cooperation, because we're talking about commitments to each other. So commitment, goals, thinking about, okay, how can we drive each other, but in a way, like you said, that is supporting each other, thinking back to what Rob was saying as well in his talk.
I connected with the word directed. I feel like in my own experience as a young learner, becoming a lifelong learner, I had a sense of being directed, or that I could create new direction when needed through a process. As an artist, that's a pretty big deal. It's different than most artists in a way. But I do think that there is not enough project-based learning in high school. I think it breaks down from middle school to high school. It is happening in different pockets, but I think that 4 years of high school really does, in a general way, impact the kids that are going to, the students that will move into deeper project-based learning in college, because they are anxious. They've lost a little bit of faith and they've gotten hooked into numbers as opposed to narrative, reflective language, words that say excellence, that say outstanding, that say adequate. I mean, when kids get adequate, they are floored, you know. Anyway, I'm appreciating what I'm hearing. Thank you.
Thank you.
Wonderful. Is there anything else that somebody has some questions about? Okay, I'm going to throw this one at you. Are you ready? Are you buckled in? How do you feel that this will contribute to future pedagogy for the instructors as they build their curriculum? How do you feel your research will impact that? So.
Sure. Well, hopefully, and Lauren, I'd like you to answer too, but just from my perspective, hopefully we can get an earlier indicator through reading a student's work, that we can get an earlier indicator of they may have a low self-confidence level, or they may be more anxious or stressed, or they may not have good motivation, allowing for earlier interventions to support them. That's kind of my main hope as we do a lot more of this qualitative research, because we're not relying on it right now. This is very exploratory, but also very exciting. That's one of my main things. Lauren, how would you answer that?
Yeah, I think thinking about personalized learning, I've taught some classes where I've had 20 students and some where I've had 90. So with the classes of 20, it's been easier for me to be able to identify, here's somebody who's having a hard time with the material, or here's somebody who's high flying, and I'm able to differentiate my feedback to them based off of where they're at and what they need to grow and to develop. Whereas my class of 90, I just gave give feedback to the average person, right? Because it was just so much harder to know all of the students and what they're feeling and where they're at. And I think that I felt better about myself as an instructor in the case where I could have a better idea of feelings and emotions to kind of target my thoughts and my communications accordingly. So being able to scale up that personalized level by just getting some clues to better support my own abilities to provide feedback in a meaningful way.
Very good. Thank you.
Yep.
That was just wonderful. Any other questions? All right. Well, thank you again. And now we'll move on to Rob. Rob is going to close us out with Orange is the New Engineering: Reflections on Teaching Engineering in an Incarcerated Setting. So, Rob, you're back in the hot seat. Thank you.
Thank you. I really appreciate the opportunity to talk about this. This is something that I undertook that was fairly transformative for me, and I found was also fairly transformative for the students in this particular setting. And I'd like to point out specifically the author list here is a little unusual. I am the primary author, of course, but then we also have the next two authors are actually currently incarcerated individuals. And then we have an author of one of the books we used in the setting, as well as the director of education. So let's begin with why we would want to teach in a prison-based setting. It turns out there's a lot of benefits to this. There is reduced recidivism. Individuals who go through education while incarcerated commit fewer crimes. Not just do they commit fewer crimes, I shouldn't say they commit fewer crimes, they are less likely to return to incarceration. Not only are they less likely to return to incarceration, but they influence those around them in positive ways. They have families. They have a social network that they will interact with. And if we provide them the right tools, then there will be impacts that ripple out from these individuals, reducing crime more broadly. Also, very importantly, there are broad societal values. Having a well-educated population in a democracy is important. In engineering, very specifically, there is a need to have diversity, to get various viewpoints and different perspectives on engineering processes. And so bringing in new voices has strong value. So the course that I set up, as I was putting this together, I was forced to think very carefully about what I should teach and how in this setting. And maybe not surprising after you look at the previous presentation I gave, you would see that I frame this in three broad areas. Engineers have to know technical stuff. We've got to know how to solve hard problems in math and physics. We also have to know how to apply what we know in the sciences and maths to design situations and iterate design to make the world a better place. And then finally, there are professional skills that are critical in the space of engineering. And so I selected 3 books for this experience. This is an introduction to project-based engineering course. I selected Math with Bad Drawings, which is a wonderful book, super fun. I recommend it as light reading. It makes math accessible and exciting. I chose The Design of Everyday Things. The first edition of this was called The Philosophy of Everyday Things. Or sorry, not the philosophy, the psychology of everyday things. This is about how people use things that are designed and how those things could be designed to be more effective in use. And then the third thing that I chose for the professionalism aspect is Crucial Conversations. This is a book that focuses on how to have good, productive interactions with other people that move things forward in ways that are effective, as opposed to oftentimes cycling back through the same conversations repeatedly. This is a way that this book provides a framework for people to talk effectively and resolve difficult situations. And it applies in business settings as well as personal settings. So moving on, once I've picked these, I had to think about the context that I was going to be doing this in, and realizing that the context And in addition to providing a unique set of student needs, also provided a really unique set of challenges. One of the chapters in the design of everyday things points out how often we interact with a penny, and how we would all recognize a penny instantly. But if you're shown a picture of 10 things that are almost pennies, one of them being an actual penny, it's really hard to pick out which one is the real penny. Does Lincoln face to the left or the right? Is the year here or there? You know, what's on the front and what's on the back? So thinking about that is a challenge. And in a traditional setting, you see that, you read that, somebody reaches into their pocket, pulls out a penny, and addresses the question. In this setting, however, there are no pennies. Money is not allowed past the front door. And so when we talked about this particular chapter, I had to come back to my office, take a picture of this penny, and load it up onto D2L. You may think this is a relatively small thing and a small issue. Posting this picture resulted in comments like, "Pictures are presents when you're in prison." They really, really valued something as simple as a picture of a penny. Shocking to me from my perspective initially. Other challenges, the kinds of materials that were used are very limited. When I'm working in my traditional program, you know, I've got this laying around, I've got this stuff back here I can pull in, and we can be talking, and I can, oh, we want to do a quick experiment, we can do a quick experiment. You know, I want tape, we've got tape right here. I got scissors. I couldn't use scissors in that space. We had some plastic safety scissors that were approved. It was very difficult to cut things with them. We made them work. And so everything I had to use had to be pre-approved. It had to be safe in the setting. And so I did a lot of activities that you would think of in a typical K-12 outreach space. Additionally, I had less control over when things happened. The day of my final, actually the day before my final, I was going to do a 2-part final. I had 2 meetings a week, and I was going to use a meeting for one part of it and a meeting for another part. These finals were actually presentations. I received word that they were shutting things down. This was COVID related, but there would be no interaction on the Wednesday. That I was actually a special case being allowed to come back for the Monday, and otherwise the prison was locked down with people coming in and out. So I had very little control over things, which is a challenge. So looking at this situation, it is important to consider different perspectives. If we think about the parable of the blind men and the elephant, where each person looks at or feels a different part of the animal and reports, you know, I found a wall because you're on the side of it, or I found a snake, or I found a tree, or I found a fan. Coming at this with lots of different perspectives does a much better job of illuminating the full experience than coming at it with my perspective alone. And so that's what this presentation really is about, and that's what the results of this presentation are from. We'll begin with the prison director of education, who recognized strong value in the class. She identified that there was an important investment in education. This was a cohort approach for the first time in this prison setting, this particular prison, which was unusual. In the state of Minnesota, our incarcerated individuals are paid. They are paid between 25 cents and $2 an hour for doing work. This was the first time that going to college, taking a college class, was considered work. Previously, it had been considered sort of a supplementary activity. And so this is really the state investing in these people in a very powerful and potent way. The director of education also saw the family impact. She heard stories about the students in this class talking to their families, being excited to go back and share the value of what they were learning with their loved ones. She also saw the learning of math become fun again. The book that I chose was more powerful than I could have imagined. And we'll talk about that in a moment, but the students in this space, she saw them being truly enthusiastic about math, which was unexpected. And then the discovery of engineering and thinking about the future, and if some of these students upon release, do they consider a career in engineering, or does this engineering experience influence their choices in the future? That this is something that she wonders. So that's one perspective. The next perspective is really an interesting perspective to provide, because it is the author of the book Math with Bad Drawings. At one point in the class, we were going through the book and somebody had a question and about something and wondered if the author hoped something was that we would get something, or what was the point of the author doing this? And I said, that's a good question. I'll send the author an email and see if I can find out. And so I looked the author up and I found out that the author actually is local. And I was able to reach out to him and say, hey, how about if I buy you lunch and we meet? And so I met with the author and we hit it off, had a lot of fun hanging out. And then after a lot of paperwork, it took a ton of paperwork, I smuggled a mathematician into prison. And so this was a guest speaker from outside. They had a chance to interact with this person. And this person, this author, Ben, had the opportunity to see how his materials were being leveraged and used by this audience. Importantly, Ben has a good perspective on both the technical aspects as well as the learning aspects. And so he saw value in both of these. He saw how these students wrestled with the material and how, in some ways, the humanness of his book, as opposed to the sterile textbook nature that you would typically find, made a big impact. The next perspective that I'll present very briefly is the perspective of a future STEM educator in a prison setting. This person provides a perspective of me months ago. They are being forced to reckon with how do they approach a limited space? How do they approach the diverse needs? They're also viewing this as a strong opportunity to think about how they teach this material and what's truly important. And so that's a very valuable perspective. These next few slides, if my students presented them, my student engineers presented them, I would sigh and hang my head because there's way too many words. However, I really wanted you to see and read the words of the incarcerated students. And so I felt it was important to have their authentic voices here. They perceived this space coming into it as a space that was going to be challenging. We go back to that stress culture, and it turns out that just seeing engineering on their schedule was intimidating. However, it also built bridges with the outside world. When they told their loved ones that they were participating in engineering class, that was something that was impressive. I'll give just another moment to so one of the things that I brought into this class, and it's tied to Crucial Conversations, was an active listening. I tried very, very hard to actively listen to the students, and that was something they deeply valued. It helped them open up and share their lived experiences and think about the way they could impact the world around them in more potent ways. Interestingly, however, one of my co-authors pointed out that I gave everybody a chance to feel heard, while at the same time pointing out that maybe some of her colleagues should not be heard. And so I found that a really interesting perspective, valuing it on the one hand, and on the other hand, seeing it as a time sink. Many of the challenges that they encountered were productive, but also they encountered a lot that were not productive to their learning. They had to deal with the incarceration, the settings of incarceration, as well as the complications of COVID. And that led to a lot of challenges. We had one student in particular that demonstrated a lack of rationality. And it was, from my perspective, very rewarding to watch them interact and practice the tools of Crucial Conversations. I also think they may not have been in their zone of proximal learning. That may have been too big a lift. So they had to fight for resources and think about how they negotiated and collected the resources they needed. And then they sometimes valued the teamwork and sometimes despised the teamwork. For the most part, I saw great growth in that space and really valued it. I'm seeing I'm spending more time than I should, so I'm going to speed it up just a little bit here. Students continued, this is more about environmental limitations. So what they had to get, getting materials took time. Navigating the systems took time. Where they could use materials was restricted. However, they also saw that this was something that they did on a regular basis. When they realized that they faced challenges and had to overcome challenges on a regular basis, it changed their perspective about the value of engineering. They grew in amazing ways. Some of the things they valued were the professional interactions. When I brought Ben into the classroom and he and I had a conversation, him from a perspective of mathematics, me from a perspective of engineering, we were able to both agree and disagree in a professional and respectful manner. That was something that resonated deeply with them. Additionally, connecting it to the real world made a difference. Helping them navigate their emotions. They experienced a lot of the same emotions that our student engineers experience in this program, and dealing with the imposter syndrome, for example, is a challenge, and helping make sure that they see themselves as valuable and worthwhile. So this changed me. I had to think about the journey. I am very much an extemporaneous teacher. I generally don't know what I'm doing in class until about 5 minutes after it started. So planning this out was a challenge for me. I also saw that the focus on communication if I were going to do this again, I would increase my focus on communication. It was already fairly heavy for an engineering course. I would increase it more. I think that I had a very good balance in connecting theory to practice. So at one point in the book, we talked about trusses, and later we saw them applying trusses in building these chairs from newspapers. I really valued, as a final thought, I really valued the growth that I went through. I have a different world perspective. I view incarceration differently. I view myself differently. And I view many of the populations that maybe are more commonly incarcerated than populations that look like me differently because of this. And that brings me to the end of this presentation with maybe a few moments for questions.
All right. Thank you, Rob. Are there any questions that anybody would like to share out? Otherwise, I've got a question. Anybody out there? Okay, Rob, I'm going to give you mine then. You ready?
I'm always ready.
All right. So there's been some research that's been done as far as engineering and content delivery with regards to the connection of equity and inclusion on understanding really the background of the people that you're trying to educate, and how can you relate what your pedagogy is to how they can relate to that engineering or that concept. Do you feel that what your learning outcomes that you had out of this has put a new direction for you? In other words, kind of asking yourself or soliciting information from your students that the value of really asking more questions as far as where they come from, and then you can frame some of your teachings around everybody's where everybody would be familiar with. My example would be is if you were in West Central Minnesota in a farming community, and you provided a project that would be something associated with a metro familiarity kind of thing, there'd be that disconnect, right? So what did you find out, and how do you feel that your learnings here can help from an equity and inclusion standpoint of making sure that the content can be understood by all, if you might say?
So that's a really, really good question. And one of the challenges going into this space was that I didn't know what my student body would look like in this space. I had a few statistics that had been, I'd sat through maybe 2-hour training on Zoom about how to, get out of, interact in the prison, what I was allowed to have. And it had a snapshot of some statistics, but I really didn't know who I was going to be dealing with. And so learning about them, really getting to know them, making myself vulnerable from the beginning and being authentic with them, created bridges that allowed them to be authentic with me. I began the course by admitting this was going to be scary, and also that I was terrified. They were scared, I was scared. And when I said that I was scared, I could see them relax and say, okay, he's scared, I'm scared, we're all scared. I had a large semester project as part of this, and I had to think carefully about that semester project and how it would connect. As you point out, if you are trying to support somebody in engineering for one context and forcing them to do it in a different context, it may be hard for them to transfer that. I spent a lot of time with others brainstorming. My wife had the brilliant idea to have them design an elementary school. And so that was their project. They had to think about an engine and design an elementary school, proposed to be constructed in about 5 years. And they had to come up with a budget, and they had to come up with How are you going to make the different stakeholders happy? And this was something that connected to all of them, whether it was because they had gone through K-12 education themselves, or whether it was because they had children who were currently in that space. This was something that resonated a lot. And so finding that resonance was truly important. Does that answer your question, Jason?
Yes, that sure does. And thank you very much for sharing that. That was awesome. Any other questions that somebody would like to pose or anything like that? What I did do is I did put in the agenda into the chat. So if you want the contact information from our wonderful speakers that we had today, I just wanted to make that aware to you as well. And the other thing is I would like to go ahead and thank these speakers as well. A round of applause is what they usually call that, a round of applause. So thank you very much for your content and sharing, your willingness to share this great stuff. So, and hopefully this helps your own pedagogy and the conversations that you have with colleagues, things about what you're thinking about and how you want to deliver content. So this is really something that we want to make sure that we help you out with. And remember, a reminder that tomorrow there'll be a survey going out, and please fill that out and help us get better with this program with more information as well. And we'll have the video available on our website also. And keep in mind your professional development. Contact me. I'll go ahead and take care of your professional development. I'll send that off to you, and you can use that as well. jason.bruns@mnsu.edu. And our next event will be happening Thursday, September 22nd. Mark it on your calendar, 2022. Yeah, what the topic might be is, let's call it a surprise right now. So thank you very much. Thank you all for attending. And I hope you have a wonderful rest of your day.